baking soda, whose chemical formula is NaHCO3 and the name is sodium hydrogen carbonate or simply sodium bicarbonate. Its preparation is basically it is prepared by passing CO2 through an aqueous solution of sodium carbonate. Means the solution having Na2CO3 in water along with the CO2 passing. So we will get 2 moles of NaHCO3. So basically it is sparingly soluble sodium bicarbonate crystallizes out of the solution. Means as it is very less soluble in water, so it will be simply crystallizes out from the solution and we will get this product which is baking soda. So its properties is crystalline solid, sparingly soluble means a bit difficult or less soluble in water. Its aqueous solution is mildly alkaline means whenever we will dissolve it in water, we will get a mild alkaline solution because of basically it is the salt of carbonic acid and NaOH. So that's why we will get some alkaline solution. A saturated solution of sodium hydrogen carbonate has a pH of 8 to 9 again, which is alkaline pH or basic pH because it is more than 7 and also a bit alkaline, not very high alkaline or very strongly alkaline. It is mildly alkaline. The solution gives yellow color with methyl orange because of the alkaline nature. It decomposes on heating, forming sodium carbonate, liberating carbon dioxide. So whenever we will heat this, it will form Na2CO3 along with the water and CO. Now it basically reacts with acids as well and evolve carbon dioxide. So whenever we react it with any acid, we will get Na positive ions means if we are reacting it with NaHCl, then we will get NaCl. The corresponding salt will what we will get. If we are reacting it with Na2, basically H2SO4, then we will get Na2SO4 and so on. So that's why it is H positive and Na positive along with the evolution of H2O and carbon dioxide. Its uses is very much wide. So it's basically the most useful compound. Its some important uses are in cooking and baking, very important. As the name suggests, used to prepare soft and spongy cakes, quick breads, biscuits, and crispy pakoras. A small quantity of this, which is baking soda, is added to a dough or batter. So what happens? Sodium hydrogen carbonate acts as a leaving agent, as it releases the carbon dioxide when comes in contact with acidic substances or heated. So whenever we are preparing something like cake, we need fluffy and spongy cakes. So we will add a bit baking soda. So what it will do is when we add baking soda in it, when on heating, the carbon dioxide gas will release, and this carbon dioxide during its leave from the cake or from the material in which we have added it, it will make the dough or batter to expand. So what happens? The carbon dioxide, which is leaving gas, slowly bubbles out and thus making the dough or batter to expand or making cake or bread to rise and produce a porous structure. Porous means somewhat holes like structure from which this carbon dioxide is escaping out. Next is in the preparation of baking powders. So all baking powders are mixture of three essential ingredients. The first one is this baking soda, which is sodium hydrogen carbonate, some substance which furnish H plus ions to react with sodium bicarbonate to liberate carbon dioxide when water is added to the baking powder. So it is normally potassium hydrogen tartarate or tartaric acid. Third substance such as starch to prevent intimate contact and reaction between ingredients 1 and 2. So ingredient 1 is baking soda and ingredient 2 is probably potassium hydrogen tartarate or tartaric acid. So while making dough for the preparation of this bread, baking powder is mixed with the flour. Whatever the starting material is, we will add baking powder with that. During baking, the carbon dioxide formed by the reaction of baking soda and tartaric acid. So we have formed now baking powder, which is again the reaction between baking soda and tartaric acid. And basically, tartaric acid neutralizes sodium carbonate formed due to the decomposition of sodium hydrogen carbonate during baking. So how CO2 is going to be produced? It is being produced by the reaction of tartaric acid along with the baking soda, or you can say sodium carbonate, sodium hydrogen carbonate. So in case tartaric acid is not present, case will also bitter. Why it is being bitter? Because of the presence of basic nature. So that's why and you know that bases are bitter in taste. So as sodium hydrogen carbonate neutralizes acid, it also uses antacid, which is anti-acid, means against acid. When mixed with water and taken, it basically relieves in acid indigestion, acid reflux, and heat burn. Basically decreases the acidity. So it is a common household antacid. So most toothpaste contain baking soda. Again, it is base as it polishes and removes stains from teeth. Also helps to kill the bacteria and eliminate foul smell from the mouth. It can be used to prevent fungal growth. It can be used to kill insects like cockroaches as well. And it can be used to get relief from some insect bites and stings and relief from some plants energy as well. So it is also used as a fire extinguisher to extinguish oil, grease fires. So sodium hydrogen carbonates, which is biodegradable and non-toxic to environment and health. So these are major uses and many wide uses of our sodium hydrogen carbonate.